Welcome to Train Signal. You're watching a video on IP address planning. In this video, we're going to start off by asking some questions that'll help us to plan an IP addressing scheme. Then we'll take a look at some of the basic rules for IP addressing. We'll talk about class full IP addressing. We'll see the difference between private and public IP addressing. And then we'll learn what network address translation, or NAT, is. Let's start off by addressing a major question, which is how do I plan an IP addressing scheme for my network? See, there are so many choices out there when it comes to IP addressing. How do I know what to do? Well, there are three questions that you can ask yourself that should help you come up with the solution. And the first question is, how many IP addresses do you need right now? How many computers are currently on your network? The second question, how many IP addresses will you need in the future? This is a very important question that a lot of IT administrators forget to ask themselves. You really need to not just plan for, let's say, the 50 computers you have on your network right now, because those 50 could become 500 in no time at all. So always plan for some degree of growth. And the third question is, are you dealing with a pre-existing IP scheme? It's very rare that we get the opportunity to walk into a network and start from scratch. Usually there is something in place right now, and then we have to figure out how to make a change to that existing scheme. So these are three very important questions that all IT administrators should ask themselves before planning out an IP addressing scheme for their network. Now let's take a look at some rules that you should understand about IP addressing. And the first thing we have here is understanding that each of the four numbers in an IP address. See here in an example I have 192.168.10.101, right? We have four numbers separated by dots. Each of those four numbers is called an octet. And oct, meaning 8, is representing the 8-bit binary number that is the IP address. When we say a bit is either a 1 or a 0. Now, I don't want you to worry too much about the binary aspect of things right now. We'll cover that in a later video. But one thing you need to know is that each octet, or each number, can only be from 0 to 255. And the reason why is because if we had an octet, or if we had an 8-bit binary number of all zeros, which is the lowest number we could have, well, that equals 0. And the 8-bit octet of all ones, which is the highest binary number we could have, that equals 255. And that's where we get our range of 0 to 255 in our IP addresses. Now another thing you should know is that the first octet, or that first number, cannot be 127. You will not see an IP address for a computer that starts with the number 127. And the reason why is because the 127 range of IP addresses has been reserved for diagnostics. Now, even though there's a huge number of IP addresses that can start with 127, 127.0.0.1 is possibly the only one that you will ever see, and it is what is known as the loopback address. It means yourself. It's sometimes even referred to as something called local host. So if you were to try to connect with 127.0.0.1, you're saying, I want to connect with myself. We'll see that in a number of different places as we go through different videos. Now another thing you need to know is that the host ID of an IP address, and in an earlier video we talked about dividing an IP address into a network ID and a host ID. Well, the host ID portion cannot be all zeros, and it cannot be all 255s. And the reason why is because all zeros represents the network ID itself, and all 255s would be the broadcast address on a network. So let me give you an example here. 192.168.10.0 represents the network ID for the 192.168.10 network. So if we had our dividing line right here, 192.168.10 is our network ID. We can't have all zeros on any of our hosts because the 0 itself is the definition of saying this network ID. And then down here we have 192.168.10.255, and I guess I could continue this line down, right? This being our network ID, 192.168.10. 255 is the broadcast address for that network. And a broadcast, as we talked about in the last video, is when one computer wants to transmit something that is meant for all other computers on the network. So that's what 0 and 255 are both reserved for. Now let's talk about class-full IP addressing. When TCP/IP and the internet were first developed, all IP addresses were divided into different class ranges. And they are the A, B, C, D, and E class range of IP addresses. And these classes can be recognized by looking at the first octet in the IP address. Here, the A class range, you will see that the first octet can have a number of 1 to 126. So any IP address that you see starting with either a 1 or a 2 or a 3 or a 50 or a 90 or all the way up to 126, that IP address is part of the A class range. All A class IP addresses have a subnet mask of 255.0.0.0, meaning that the first octet makes up the network ID and the last 3 octets make up the host ID. Now the B class range of IP addresses can be recognized again by that first number being anywhere from 128 to 191. Now you'll notice that the A class range, that first octet ended with 126 and the B class starts with 128, and that's because of what we were just talking about a moment ago where 127 is not allowed. That has been reserved for diagnostics. So with the number beginning with 128 to 191, you're in the B class range, which has a subnet mask of 255.255.0.0, where we now have the first 2 octets making up the network ID and the last 2 octets making up the host ID. The C class range, we begin with 192 to 223 and have a subnet mask of 255.255.255.0. Now these are the only 3 class ranges that you can assign IP addresses to a computer. There are other 2 classes, but those are reserved for something else. The D class range is reserved for multicast addresses. You may recall from the last video we talked about multicast communication, where a number of computers will all subscribe to the same address to receive a communication. Well, that is what the multicast range of addresses are reserved for. And then the E class is reserved for experimental. Let's go back to our A, B, and C class for just a moment, since these are the ones that we can actually assign to our computers or to our hosts. Now with the A class, because the first octet is the only one used for the network ID, there's only 126 networks. That's it. Very, very small number, and guess who has them? Yep, the ISPs. The internet service providers of the world have those 126 networks, but that's okay because that's really who should have them, because each one of those networks, although there aren't that many, each one has almost 17 million IP addresses available to hand out to hosts or to computers. That's where it kind of makes sense that the ISPs have them. Now with a B class range of IP addresses, you will see here that there are 16,384 networks, and that's because the first 2 octets are used for the network ID. So we have many more networks available in the B class range, but each one of those networks only have about 65,000 host IP addresses available. Now, most of these networks were used by major universities and things like that. And then we have our C class range, and you'll notice that there are quite a few C class networks available, a little over 2 million of them. But each one of those ranges are limited to only 254 host IP addresses. So now we have our smaller companies who can each take one of these C class networks because only 250 hosts are going to be available for them. Now there are a total, altogether, if you were to add this all up, there's a total of a little bit under 4 billion total host addresses available. when it comes to classful IP addressing. Well, do you think that that's going to be enough for everybody in the world? For all the computers we have in the world? They sure thought so when they first created this, but it's seeming like we are running out of IP addresses real soon. And as a matter of fact, in a later video, we will very specifically address what we've done to try to make more addresses available. Now let's talk a little bit about private versus public IP addressing. There are certain private IP ranges that have been reserved from public internet use. So there are certain ranges of IP addresses that are not accepted by the internet routers. You cannot travel the internet if you're using these IP addresses. There's an A class, B class, and C class range that have been reserved. The A class range is 10 dot anything. See here we have 10.0.0.0 to 10.255.255.255, but really that just means 10 dot anything. The entire 10 A class network is unavailable on the internet. Can you believe that? There's only 126 to begin with. Well, now we've taken one away. A B class range that's not available is, there's actually a number of B class ranges. Anything from 172.16 through 172.31. So 172.16 dot anything, 172.17 dot anything, 172.18 dot anything, all the way through 172.31 dot anything is unavailable on the internet. And then the C class range is 192.168 dot anything. Now a lot of people think of this as a B class range because they hear it as just the first two octets, but technically it's 192.168.0 dot anything, 192.168.1 dot anything, all the way up through 192.168.255 dot anything. So there's 256 C class ranges that have been reserved. These are all private IP ranges that are not valid on the internet. Now you may have seen this fourth one I have down here that says 169.254 anything. That is a B class range, and no, those IP addresses are not valid on the internet, but those are not typically used in a private network intentionally. That is a range of IP addresses that has been reserved for something called automatic private IP addressing, which is where a computer can self-assign itself an IP address when it has been configured to receive its IP address dynamically and there's no DHCP server available to give it an IP address. These IP addresses are for smaller internal use only networks. But the main IP address ranges that I want you to focus in on are these three right here: the 10 network, the 172.16 through 31 network, and the 192.168 network. Now, hosts that have been assigned these private IP addresses can get to the internet if they use a technology called Network Address Translation, or NAT. And we're going to talk about that in just a moment. But one thing you should understand is that, believe it or not, most of today's companies do use these private IP addresses on their private networks. And some of the reasons why are, well, we talked about how we're running out of IP addresses, and I'm going to explain NAT to you in just a moment, and that is going to show you how a network of thousands of computers can travel the internet using only one live internet IP address. A second reason is for security. By using a private IP address that is not valid on the internet prevents a potential intruder from attacking that computer from the internet because it has an IP address that's not valid out there. Now I know that might sound a little bit confusing, and we will clarify this in later videos, but that's some of the reason why companies are using private IP addressing. If you want to use public IP addressing, you can, but then you would have to get a valid range of IP addresses in the A, B, or C class ranges. So what is this NAT thing anyway? Well, NAT stands for Network Address Translation, and I have here a diagram of a very simple network to try to help illustrate how NAT works. So in this diagram, we have three internal clients. We have these three clients right here who are all using private IP addresses, right? We have client 1 with 192.168.10.101. Here we have 102, and here we have 103. Now these 3 clients, although they have private IP addresses which are not valid on the internet, right? If these 3 wanted to try to go directly to the internet, it cannot be done. These 3 clients want to be able to get on the internet, and so they're going to travel through this NAT server. Now a NAT server is a box that has 2 or more network cards, and one of the network cards must be configured with an internal private IP address that matches the internal clients, and an external live IP address which is connected out to the internet. Now what's going to happen here is, let's say client 1 wants to go ahead and connect with a web server out on the internet. Client 1 is going to send that request to the internal IP address of the NAT server. The NAT server will then take that request and will say, let me go ahead and store that in my memory so that I know that client 1 is looking for this particular web server. Then I'm going to change this particular request so that the source IP address is my external internet IP address, and then send it out on the internet until it is received by the web server. Now the web server doesn't know who actually sent the request. The web server believes that the NAT server sent the request, so the web server will send a reply back to this NAT server. It'll send it back to a destination of 131.107.56.103. When the NAT server receives this request, it says, I wonder who was looking for this web server. And it looks in that memory log that it made, and it says, client 1 was looking for it. So I'm going to go ahead and again change this particular response to putting a destination IP of the client's IP address. And that way we send that request back to the client who originally requested it. That's how NAT works. And that would work for any one of these clients. If any client were to send that request onto the NAT server would change the request so that it looked like it was coming from itself, send it out to the internet. Any web servers that receive that request will send it back to the NAT server thinking that that's who actually was making the request. The NAT server would look in its memory banks to say who was actually asking and would change the response back and send it back to the client who was requesting. And in that fashion, we can now have an internal range of literally thousands and thousands and thousands. There is no specific maximum to how many internal IP addresses can go through a single NAT server. It really has to do with the hardware that you have available to you. So that is one way that we've addressed the issue of the limitation of IP addresses that are available out there in the world. Okay, well, you should now understand how to plan an IP addressing scheme, know what the basic rules for IP addressing are, understand class full IP addressing, know when to use private versus public IP addresses, and understand what network address translation is.